So we got sequences and series. We need to see if they converge or diverge. All right, Emma's going to read first. Here we go.
A sequence is simply a list of things generated by a rule. More formally, a sequence is a function whose domain is a set of positive integers or natural numbers n such that the range of the function are called the terms in the sequence.
All right, so you're just substituting in. So where a of n is the nth term, and that's the rule. And we denote that by a sub n. All right, so the sequence can be expressed either by...
A sequence can be expressed by either an ample number of terms in the sequence separated by commas, an explicit function defined by the rule of sequence, or the rule of sequence set off in braces.
All right, so a lot of the times we'll just substitute in and we'll start seeing a pattern, and we get that pattern and we get a rule, and that rule is going to be our a sub n. All right, let's go to example 1. B. Rice is going to read for us.
The sequence 2, 4, 6, 8 is a sequence of even numbers. Express the same sequence as a rule of non-negative integer n. Sequence 1 through 5.
All right, oh, hold up. So we got 2, 4, 6, and 8. That 2 is my first term. The 4 is my second term. My 6 is my third. My 8 is my fourth term. So what kind of pattern do you see going on here? They're increasing by 2. And when you add, that's really multiply. And so my a sub n is actually 2 times n. Following me? All right, let's keep going.
Sequence 1, 3, 5 is the sequence of odd numbers. Express the same sequence as a rule of a non-negative integer n.
All right, so 1 is my first, 3 is my second, 5 is my third. So again, they're increasing by what? 2. So it's 2 times n, but then what? We have to subtract 1. All right, so my a sub n is 2n minus 1. All right. So example 2. So now this is my a sub n. This is my rule. And I need to list out the 5 terms, and then I'm going to take a limit to infinity of my rule. So let's do my first term. So if I substitute in 1, what do I get? 4/5. Now, if I substitute in 2, this is a sequence, so they're going to be separated by commas. So if I substitute in 2, what do we get? 8/7.
So, do you want us to write like a sub 1 equals
Nope.
4? Just write
Nope,
that?
just write it in a list of commas. Now, truly, we're thinking if this is my first term, this is my second term, and so forth. All right. All right, so then if I substitute in 3, we don't have to simplify. What do we get? 12/9. I'd actually prefer you not to simplify. You're going to see patterns if you don't simplify. All right, and then I substitute in 4, and we end up with 16/11. And then 20/13. All right. So now it's asking me to find a limit as n approaches infinity of a sub n. Well, my a sub n is this 4n over 3 plus 2n. So if I substitute in infinity, they're both growing at the same rate. So what do we get? We get 4 over 2, which is 2. All right. Pretty good? All right. So if I have a sub n as this, we got to do we have to figure out a few things. If I have a limit and it goes to infinity, then my a sub n diverges to infinity. All right? Because what does diverge mean? It doesn't add up fast enough. It keeps adding up. All right? So if I have a limit to infinity and I get negative infinity, again, the sequence diverges to negative infinity. If I get a number, if I get a true number, then that converges to that number. Does that make sense? The sequence converges to that number. And then we can have oscillation, and that'll oscillate. Now, I want to talk about happies, or factorials, in which they're really called. So if I have, let's say, 6 factorial. 6 factorial is really 6 times 5 times 4 times 3 times 2 times 1. Now, another way of saying that is it's 6 times 6 minus 1 times 6 minus 2 times 6 minus 3 times 6 minus 4 times 6 minus 5. All right, that's no. All right. So here we go. Let's put this into practice. Determine whether the sequence will converge or diverge. Now, what we have to do is we need to take a limit to infinity of our a sub n. All right, so we're finding a limit as n approaches infinity of this one, this n over n plus 1. Well, if I substitute in infinity, what do I get? 1. So that is said to converge to 1. Or converges to 1, I should say. All right. So let's look at part B. So now, what's my a sub n of part B? 1 over 2 to the power of n. All right. So now if I take a limit to infinity there, what do I get? I get 0. So what do we know? The sequence converges to 0. All right, let's look at part C. So now I'm going to do a limit as n approaches infinity of a sub n, which is 3 plus negative 1 to the power of n. Now, what happens here? Do what? No.
Does it oscillate?
It oscillates. Because if I start substituting numbers, when all else fails, let's start substituting numbers. So if I substitute in 1, what do I get? I get 2. If I substitute in 2, what do I get? 4. If I substitute in 3, I get 2. And then 4, and then 2, and then 4. So what's happening? It oscillates. It does not exist because of oscillation. All right. It oscillates between those two fixed numbers. All right, let's look at part D. So now I have a limit as n approaches infinity of a sub n. So what do? Substitute in, what happens? What do I get? I get negative 1/2. So my answer is converges, my sequence converges to negative 1/2. All right, let's look at part E. So now I'm going to take a limit to infinity of a sub n when a sub n is natural log n over n. Now, this is really a L'Hopital's rule. However, we know speeds. Who wins? The bottom wins. And when the bottom wins, what do we get? We get 0, and that's a great thing. All right, so that converges, that sequence converges to 0. All right, let's look at F. All right, so now I have n factorial over n plus 2 factorial. Now, in pre-calc, we did this a little bit. Which one's bigger here? The bottom's bigger. And so I want you to start canceling some things here. N plus 2 factorial is n plus 2 times what? N plus 1, right? You're subtracting 1 each time, remember? So this is n plus 2 times n plus 1 times what would be my next term? N. Now, I personally would say n factorial because we could keep going on forever and ever, right? But what can cancel out now? The n factorials, because those go to 1. So truly, my a sub n is 1 over n plus 2 times n plus 1, right? So now, if I think of that as my a sub n, if I take a limit as n approaches infinity of a sub n now, who wins, top or bottom? Bottom wins. So what does it go to? 0. And so that sequence converges to 0. Pretty good? All right. So here we go. So now I have 2 n factorial over n minus 1 factorial. Now, which one's bigger? N factorial or n minus 1 factorial? N factorial is bigger, right? And so let's change it up a little bit. So now I'm going to say 2 is out front, and then I have n, and then what's next? N minus 1. and I'm going to put a factorial on it there. Why do I put it there? Because it will keep going. So now I can cancel out my factorials. See how that worked? So really my a sub n is 2 times n, right? And so now if I have a limit as n approaches infinity of a sub n, what does it go to? Infinity. So what does that mean? It diverges, all right? Technically it diverges to infinity here, but it diverges, we're done. All right, let's look at h. So now we have n plus negative 1 to the power of n over n. So if I take a limit as n approaches infinity, what do I get? You don't know?
Does it oscillate?
It doesn't. Let's talk about why. If we substitute in 1, what do we get? 0, okay? If we substitute in 2, what do we get? I think it's 3/2, right? If we substitute in 3, we end up with 2/3 actually. Then if we substitute in 4, we end up with 5/4. And then 7/6, and then 6/7, and then 8. Oh, not 8. I don't know what our next one is. But we could think about it that way. But can you see a pattern a little bit? Do you see what it's getting close to? Not really? Okay, so we're going to distribute dividing. All right, this is a monomial on the bottom, and I have a binomial up top. And so sometimes I like to think about it as distributing dividing. So my a sub n is equal to n over n, which is what? 1. And then plus negative 1 to the n over n. Now, if I do a limit to infinity now, we get 1 plus what? 0, which is what? 1. Now, the further you go out, the bigger the number we have. Okay, 58. If we substitute in 58, we get 59 over 58, right? We substitute in 59, we end up getting 58 over 59, right? Do you see how it's getting closer and closer to 0? If we do 58 billion, all right? I get 58 billion and 1 over 58 billion, right? It's going to get really, really, really close to 1. All right, let's look at part I. So now if I have to do a limit to infinity, I now have a limit as n approaches infinity of a sub n. Now, let's kind of think about this. If I substitute in infinity, this negative 1 to the power of n is doing what to my... It's coming between negative and positive, right? This n minus 1 over n, what does that portion go to? That portion goes to 1. So what's happening is that we get a negative 1 and a 1. That's really what it's starting to do. So, does my limit to infinity exist here? No, that does not exist because this oscillates. All right. All right, part J. Okay, part J. So now I have 2 to the power of n over n plus 1 factorial. Okay. Now, this is where speeds really come into play for us because this one's actually a pretty hard one to prove without knowing some things that we're going to figure out in this chapter. All right. So let's talk about speeds. Who's the slow one? Logs, right? Logs are slow, right? Then what? Polys. Then what? Exponential. Then what? Factorials. Then n to the n or x to the x. All right. So I have an exponential over a what? Factorial. Who wins? Let's try this again. I have an exponential over a factorial. Who's faster? Factorials are faster. So the bottom wins, so I end up with 0. All right, and that is truly by speed. So this converges to 0. This is technically converges to 1. All right, let's look at K. All right, wow, this is something similar. Was this on your test? Man, my goodness, this is crazy. This is crazy. So if I have a limit as n approaches infinity of a sub n, I don't need you to prove it now. What is it? What is it? E to the first. It's e to the first. Why is it to the first? Because the 1 over the n. All right. Just like your test, it was a 3 over n. It should be e cubed. All right, this next one. So again, I need to know my speeds here. Oh, so it converges to e. So now if I have a limit as n approaches infinity, I have a factorial up top, and I have an n to the n on the bottom. Who wins? The bottom wins. So what happens? We get 0. So it converges to 0. All right, pretty good? All right. So now we're going to get to the hard part. All right. I need a reader. Thank you so much, Ham.
Sometimes, albeit rarely, we have to write the rule of sequence as a function of n from a pattern.
Mm-hmm.
Write an expression for the nth term.
All right. So there's really not too many ways to really explain it, except I would highly advise you saying this is your first, second, third, fourth, and so forth. All right. Now, this first one's not too bad. What's happening from 3 to 8, 8 to 13, 13 to 18, and so forth? It's adding 5. And so if you think back in our pre-calc days, when we added 5, that was really what? Multiplying. So it's 5 times n. However, I need to start out at 3. So what do? Subtract 2. All right. So now if you just substitute in, let's say 3. If I substitute in 3, I better get 13. Does it work? Yes. All right. All right, let's look at part B. So now I have 5, negative 15, 45, negative 35. Now, I want to get rid of this alternating thing first. You see how it goes from positive, negative? So I want to kind of talk about that one first. So that's going to be a negative 1 to the power of something. Now, is that a power of n or a power of n plus 1? Because I start out positive. It's an n plus 1. Because I start out positive. So that would say power of negative 1 to the n plus 1, or n minus 1, technically, it could be. All right? So now it's kind of like 5, 15, 45, 135. What's happening there? It's multiplying by 3. When we multiply, do we remember what that is? That's exponential. So this is 3 to the power of what? N. All right? It's 3 to the power of n. But I want to start out at what? I want to start out at 5. If I substitute in 1 right now, I get 3. I want to start out at 5. So the way that I take care of it is I'd say it's n minus 1. Because let's just start out at 1 here. And then I'm just going to multiply by 5. All right? So if I wanted to simplify this up, I'd say negative 1 to the n plus 1 times 5 times 3 to the power of n minus 1. Now, let's just go ahead and check it. So let's put a 3 right there for 45. If we substitute in 3, I'd start out with a what? Positive, right? All right. And then that's a 5, and then it's 3 to the power of what? 2. So 5 times 3 squared is 45. So we're all good now. All right. So there is my a sub n. All right, let's look at part C. I got 1, 4, 9, 16, 25. This one should be fairly simple to pick up on this pattern. I squared it. All right, I just squared it. So a sub n is equal to n squared. All right, let's look at this next one. This is a little bit tricky, but I'm going to hopefully help you out a little bit. So I got 4, 10, 28, 82. You look at it and you're like, daggone it, I'm done. However, what if we think about it as like 3, 9, 27, 81. Those are really close to those other ones, aren't they? Are they pretty close? Pretty close. However, how off are they? Just 1. So at the end, we're going to just do what to it? We're just going to add 1 to it. All right, so how do we get from 3, 9, 27, 81? What's happening? We're what? We're multiplying, right? So that's really what? Exponential. So my a sub n is equal to 3 to the n. And then what? Plus 1 at the end. All right. All right, let's look at part E. Whenever we have fractions, I would highly advise you to work with the numerator and denominator separately. Okay, that's how I would kind of break it down. So if I have 2, 3, 4, 5, 6, what's happening? I'm adding 1. So if I'm adding, that's really what? Multiplying. So I have 1n up top. However, I want to start at 2. So what do I need up top? Plus 1. So I have n plus 1 up top. Then I have 1, 3, 5, 7, 9 on the bottom. What's happening? I'm adding 2. So what does that mean? I have 2n. However, I want to start off at 1. So what should we do? We should subtract 1 in the denominator. All right. On fractions, I would highly advise you working with the numerator and denominator separately. Don't try to work with them completely together. Does that make sense? All right. All right, let's look at part F. Natural log of 1, natural log of 2, natural log of 4, natural log of 8. All of them are going to have what in it? Natural log. So just put natural log, and then let's deal with the numbers. You following me? So now I'm going to deal with 1, 2, 4, 8. Well, what's happening? What? I multiply by 2. So now I have 2 to the power of n. Now, if I substitute in 1 right now, though, I should get what? Natural log of 2. Well, that's my second term. I want it to be my first term. So what should we do with the exponent? I subtract 1 in the exponent. So I have 2 to the power of n minus 1. All right, see how that worked? All right, so those are a little bit tricky, but you'll get it. All right, sequence worksheet from your worksheet packet. Have fun.